Until this moment, we only dealt with a passive view, which receives updates from the server, but that doesn't provide any user interaction. In this lesson, we are going to see how to handle user interactions in our view, going through many examples on how to use bindings, show live flash messages, button clicks, and form events. So let's start with a super simple example, a clear button that clears this trades table. It's not really useful, but it gives us an example simple enough to start understanding how user interactions works in LiveView. So let's go in our crypto dashboard live module and add our button. So at the top of our template, we add a button tag, clear button. And we add a binding, Phoenix click, with a value, clear. So when this button is clicked, it sends a clear click event to the server via the Websocket. And how to handle this event? With a callback. So we implement a handle event callback, where the first argument is the event name. So we can pattern match this name, clear. Then we will see later what the second argument is, and then the socket. So when we click this button, the browser sends to the server a clear event, click event, and the server handles the event using this callback. So we need to clear the trades table, and we do it reassigning to the socket a new trades map, which is empty. And we return the updated socket. So as simple as this. So we have our clear button, and if we click it, you see that we clear the trades. Let's see what are the messages. So when we click the clear button, we see this event. So it's an event message, type click, and the event is clear. So the browser sends this event, which is handled by this callback, and we set an empty trades map. The view is re-rendered, and the server then pushes the changes down to the browser. Using a different binding, a Phoenix value binding, value, and here our key, the name of our parameter, we can send values along with the click event. So let's see a different example where our trades map and products list are empty. So we go here, we remove all this part. So we have an empty trades map, no products, so which means having an empty table at the beginning. And we want to add a product in the table just clicking a button. So for simplicity, let's think to have just one button to add the Coinbase BTC USD product, which sends a click event, add product. So here we have Coinbase BTC USD. Let's say add Coinbase BTC USD. And we use the Phoenix value binding to pass the exchange name. So in this case, it's fixed. So we write it here, Coinbase. Okay. Then the currency, a pair. So let's call it pair, BTC USD. So here, these two bindings, Phoenix value exchange and Phoenix value pair, are a way to send the exchange and pair parameters to the handle event callback. So let's go here. I've removed the clear, handle event callback for the clear event. So we have handle event add product, and here we have our parameters. So it's a map, and we have the exchange name, so exchange parameter, exchange, and the pair parameter, pair, and the socket. So here we use product new, passing the exchange name and the pair to have a product. This returns a product, exchange name, exchange, and currency pair. So we use this function. We need to alias here poetic coins product. And for simplicity, we don't validate the exchange and pair values that come from the browser, but we should check that the resulting product is one of the allowed ones. Then we use a function we call add product, socket, product to add this product to the table here and return the updated socket. So to add a product, I prefer to write the logic in a separate add product function, which, let's see what it does. Add product, socket, and this function returns a socket, an updated socket. So what it does, it subscribes to the pub subtopic to get new trades. So we use pointy coins, subscribe, subscribe to trades, passing the product. Then we want to add the product to the products list in the socket assigns. So we pipe the socket into the update function to update the products list. So here we just append the product. So this returns a new list with the product appended. And then we update the trades map, and we populate the trades map with the most recent trade for this product. So let's write it with the function, passing this function. And so first we get a trade from the historical. So poety coins, get last trade for the product, and we return a new map with the trade, with this trade for this key. And this update function returns a socket. So this add product returns a socket, a new socket, and here we return a no reply and the updated socket. So here now we have this add Coinbase BTC/USD, and we see that clicking it, it adds our product. We also see that clicking it, we have our event. And in our event, we have the values exchange, Coinbase, and the pair BTC/USD. And after clicking it, the server subscribes to the pub subtopic and sends back the updated view and the changes, the differences. And then since the process is subscribed to receive new trades, the browser receives all the new trades. There is a problem though. If we click the button multiple times, the product is added multiple times. And even worse, it means that the live process subscribes multiple times to the same pub subtopic, which means receiving multiple times the same trade. We can avoid it by simply add another function. We can call it maybe add product socket product. So this function checks if the product was already added before calling the add product. So we check that product is not in socket assigns products. So if it's not in assigns products, we add the product. So we pass the socket and we pass the product, else we just return the socket, so we do nothing. So instead here of calling add product, we call maybe add the product. So let's try it again, and we see that now clicking it multiple times, it works correctly. It adds the product just one time. With the previous examples, we got an idea on how user interaction is handled by live view. But a button for each product isn't really practical and nice to see. So it's far better to have a form with a select dropdown, which lists all the available products. When we submit this form, a submit event will be pushed to the server with the form data. And this data and this event is going to be handled by the handle event callback. So we remove this button and we write our form. Form, action, we have to write the action with the hash, and then a binding, which is Phoenix submit, which is our submit event, add product. And then inside this form, we write our select tag. So you can use the form for. In this case, we're not using Acto, but if you're using Acto and change set, you still can use the form for with the change set like a normal view. But in our case, instead of using the form for function, we use the a form tag with the Phoenix submit binding, which sends the add product event, and our select tag. So we set the name, and this name, so this name here is going to be the key of our value. So this key inside here, which we can call product ID, is going to be the key of our parameters, like this. And inside here we list all the select. We list all the options. So first, a disabled option, selected, disabled, add a crypto product, something like this, using a comprehension for. So we'll use the Poetic Coins available products function. And for each product, we have an option value. A product, remember, implements the string charts protocol, which means that we can convert it to a string. So the product will be converted to this string: exchange name, colon, currency pair. So here, our product ID can be the string. So string product. So this will convert, for example, Coinbase BTC USD to a string like this, Coinbase BTC USD. So then we can parse the string and get the product, recreate the product struct. And the product name. So we can say product exchange name, and then product currency pair. So in this way, we render the exchange name and the currency pair, and then we need a submit button. So we could use submit, but we could also use a normal input type submit value add product. Okay, so when this event is sent, this parameter product ID is sent with this ID and is handled by the handle event callback. So in this case, this parameter will be product ID, and to get the exchange name and currency pair, we need to split the product ID string. So, and also it would need some validation, but here for simplicity, we skip the validation on the exchange and the pair. So we just split the product ID with a colon symbol. We get the exchange name, the currency pair, and then we get our product, and then we just use the functions add product and maybe add product we've created before, and we get our select dropdown with the add product button. So we try to get BTC USD, then Ethereum USD, and if we try to add the same product again, since we call maybe add product, as you can see, it does nothing. But it would be better to have a message. So we can use flash messages to have a feedback of what's going on. So inside here, maybe add product, we can use the flash messages. So remember that in the layout, so here in the live layout, we have these two tags, and inside here we can render an info or an error flash message. So to render flash messages, we just need to change the socket. So remember that add product returns a socket. So we can pipe the socket in. And here we know that a product was successfully added. So we use put flash. So in this case, it's an info message. We could say product exchange name, product currency pair added successfully. Okay, a bit long, but and then we here it means the product is already in our table, so we can show an error message. The product was already added, something like this. So if we try to add, so the first time BTC USD, add product, and you see that we have a flash message, and if we click on it, it disappears. And if we try to add the same product, we have the error message. So this input tag, submit, can be a button, can be also a button. So we can convert it to a button, add product, button. By adding the Phoenix disable with binding, so here the loading text, we tell live view to disable this button and show a loading text while the server processes the event. So when we submit the form, this button is going to be disabled, and instead of add product, the button will show this loading text. But if we try it out, we don't see anything, because since we're running this application locally, it's really fast and it's hard to see the loading label. However, we can enable the live view latency simulator on the browser, opening the inspector and going in the console and calling live socket, enable latency simulator, and passing the number of milliseconds we want. So in this case, 1 second of latency. So if we now refresh and we try to add a new product, we see the loading label and the disabled button. If we want to disable the latency simulator, we just need to call disable latency simulator. Let's now see the WebSocket messages when we submit the form. So let's select BTC/USD Coinbase, and we see that this time the event is type form, the event is add product, and here we see the form data. And then Phoenix replies with the updates to patch the DOM. So inside the form, with the fork comprehension, we'll list the option tags for the products returned by the Poetic Coins available product function. So we need to be careful when calling functions to get data inside the template. Because LiveView doesn't know anything about our function, and it's only able to track the changes when one of the assigns change. So in this case, this function is a pure function and returns always the same list of products. So we can use it inside the template. But in general, a good practice is to never load data inside the template. Instead, we should bring data via the assigns so that LiveView can easily track the changes. But in this case, since this function returns always the same data, this is like having data inside the template. See now the Phoenix change binding in a form. So let's take another form. Action Phoenix change, which means that this event will be triggered for any change of the fields inside this form. And we can call it filter. And we will use this event to filter the products inside the table here. So we can call it filter products. And inside here, we put an input, type text, name. We could call it search. And that's it. So we need a handle event callback that matches this event and this parameter. So filter products, handle event here, handle event, filter products, search, text, or we can search socket. Instead of filtering the products here and assigning the result to the socket, we can use a function. So let's go here in mount and let's add a filtering function. We can call it filter products, and it's a function where we pass a product to this function, and based on a filtering rule, it returns true or false. In this case, we want that the initial filter products function always return true. So product. And here we assign a new function because we want to filter the products based on this search string. So socket, assign to the socket a new filter products function, and in this new function, what we do is to check if there is the search string inside the exchange name, or if the search string is inside a currency pair. It's a simple rule. You can obviously set your own rule. We return no reply socket. Okay, so we've assigned this filter products function, which is a function, so we don't have anything to show in the template, but we can use this function to filter the products here. So we use the filter products function passing the product. So this filtering function returns true when this product matches the search string. Okay, let's try it out. So I've added some, not all the products, but most of them. So now when we write Coinbase, you see that we have only Coinbase, but when we write BTC, we just have the BTC, the currencies with BTC, or USD, just the currencies with USD. Let's see the messages. So now we can see that, for example, if I write BTC, for each character, for each change, the browser sends a message. So you see here form, event, BT, and BTC. So in this case, we can rate limit this event using the Phoenix debounce binding in the input tag. So we go back, and here in the form, in the second form, here in the input, we use Phoenix debounce and the number of milliseconds, like for example 2 seconds. So this means that the event will be delayed by 2 seconds. And we now notice that when we write, the event is sent just after 2 seconds. So maybe this is too much. So let's go back and write, for example, 300 milliseconds. And we see that just after completing the word, the event is fired. There are many other useful events like key events, focus blur events, and JavaScript hooks. In the advanced section of this course, we'll see in detail how JavaScript hooks work, but we can't see and use all of them in this application. So I strongly advise you to start from what learned in this lesson and take a look at the official live view documentation. You find the link in the description below to explore the other type of events.